All right, now we're going to do, we finished problems with chapter 6. Now we're going to go back and look at combining a few of the previous chapters together. And this reaction has a few different concepts that you need to know. One of them is we have aluminum metal reacting with a strong acid. So when we have that happen, one of the products that we get out of it is H2 gas. We also need to balance this. So we have aluminum reacting with HCl to give ACl3 plus H2. Okay, but that's not going to work. Let's do that. Okay, so ultimately here we have two aluminums reacting with HCl, 6 HCls, to give 2 aluminum chlorides and 3 H2s as products. And this problem, you need to also identify this as a limiting reagent problem because you have a mass of one reactant and you actually have a concentration and a volume of the other reactant. So we need to figure out which one will dictate the amount of product that forms. Well, the first one's going to be similar to things that we looked at in chapter 3. So 50 grams of aluminum. We use the molar mass, 26.98 grams of aluminum is 1 mole. And then 2 moles of aluminum makes 2 moles of aluminum chloride. And then I need my molar mass for aluminum chloride. Okay, which is 133.33 grams of aluminum chloride. 1 mole of aluminum chloride. Okay, 247 grams of aluminum chloride. Okay, and we don't know until we do the second calculation whether this will be the theoretical yield or whether this number here will be useless. So the second part, we start with our 500 mLs of HCl solution. And from its concentration, we know that there's 0.300 moles of HCl in 1,000 mLs of the solution. Now we use our mole ratio. We know that for 6 moles of HCl, we get 2 moles of aluminum chloride. And finally, we use our mass, 133.33 grams of aluminum chloride is 1 mole. And this is 6.67 grams of aluminum chloride that's formed. Okay, and this is the smaller, so just like in chapter 3, the limiting reagent is whichever one gets the smaller yield. The smaller yield is the true theoretical yield, and then the other number is useless, so we predict 6.67 grams of aluminum chloride will be formed.